This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. We're diving into the fascinating world of self-adaptive LLMs today. Specifically, we're focusing on a new model called Transformer. It promises a real revolution in how AI learns and adapts. So, what initially caught your attention about this research?
The sheer audacity of it. The idea of an AI that essentially rewires itself to tackle new tasks without extensive retraining is just groundbreaking. It's a significant departure from the static models we've been working with.
Exactly. It's like giving an AI the ability to learn like a human brain, right? So, what are the key mechanisms behind this self-adaptation?
At its core is singular value decomposition, or SVD. Think of it as dissecting the AI's brain to understand its knowledge pathways. Then it uses reinforcement learning to fine-tune these pathways for specific tasks.
So it's not just about adjusting weights, but actually identifying and optimizing specific components of the model's knowledge base.
Precisely. It's a more targeted and efficient approach than previous methods.
Let's delve deeper into this SVD process. How does it help the model understand and adapt to different tasks?
SVD breaks down the complex weight matrices into smaller, independent components. This allows the model to selectively enhance or suppress the influence of these components depending on the task. It's like having a set of specialized tools for different jobs.
So it's like a surgeon precisely targeting specific areas of the brain to improve function. That's a very elegant approach.
Yeah. An apt analogy. And the beauty is that these components can be shared across tasks, making the adaptation process even more efficient.
The paper mentions singular value fine-tuning, or SVF, and reinforcement learning. How do these techniques work together?
SVF uses reinforcement learning to learn these Z-vectors, which essentially act as amplifiers or dampeners for the different components identified by SVD. It learns which components are crucial for each task.
So the RL helps the model learn the optimal combination of these components for different tasks. It's like learning the perfect recipe for success.
Exactly. And the remarkable thing is that it requires minimal additional parameters, making it very efficient.
The paper describes 3 different strategies for task adaptation during inference. Can you elaborate on those?
Yes, there's prompt-based adaptation, where a special prompt helps identify the task, classify-based adaptation using a trained classifier, and few-shot adaptation, which cleverly combines multiple Z vectors.
So it's a multi-pronged approach to ensure robust adaptation, regardless of how the task is presented. It sounds like a flexible and resilient system.
Precisely. It's designed to handle various scenarios and input types.
The paper presents some compelling results comparing Transformer to LoRa. What were the key findings?
Transformer significantly outperformed LoRa in efficiency and task-specific performance across various tasks, including math, coding, and reasoning. It's a clear demonstration of its superior adaptability.
And what about the cross-model transfer of knowledge? That's a particularly interesting aspect.
The results showed that Z-vectors trained on one model could be successfully transferred to another, leading to performance improvements. This opens up exciting possibilities for knowledge sharing between models.
The analysis of few-shot learning revealed some unexpected combinations of z-vectors. What did that suggest?
It showed that complex tasks often benefit from combining expertise from seemingly unrelated areas. For example, solving math problems might involve leveraging not only mathematical knowledge, but also programming and logical reasoning skills.
So it's not just about specialization, but also about the synergistic combination of different skills, a holistic approach to problem solving.
Exactly. It highlights the power of integrating diverse knowledge sources for optimal performance.
Looking ahead, what are the broader implications of this research?
Transformer represents a significant step towards truly self-adaptive AI systems. It opens the door to AI models that continuously learn and evolve, adapting seamlessly to new challenges and environments.
It's a vision of AI that's much closer to human intelligence, capable of lifelong learning. A truly remarkable achievement.
Indeed, it's a paradigm shift in how we think about AI development.
This discussion has been incredibly insightful. Thank you for sharing your expertise on this groundbreaking research. Before we wrap up, I want to give a shout out to Jay Poole from Tech Frontiers YouTube for his insightful content on AI. And to our listeners, what are your thoughts on the future of self-adaptive LLMs? Share your opinions in the comments below.